equations. Now we have three variables: volume, pressure, and temperature. And out of three variables, only two variables can be independent, and the third one would be dependent on these two variables, because in this equation dv and dt is separated and there is no mentioning of dp, so we are taking v and t as independent variable, because it would be easy for us to deduct equation when we take dv and dt 0 in different equation. First we will take dv equals 0, then we will take dt equals 0, then we will see what can be deducted from them. That's why we are taking v and t as independent variable. If we had dp in place of dv, so we would have taken dp p as an independent variable. So this equation d would be true for all values of dv and dt, whatever it is. Obviously we are only taking 0 1 at a time for both of these, but it would be true for any value of dv and dt. So taking dt equals 0 but having different volumes, which means dv is not 0, so the final state and the two state the difference of final state and initial state is not 0. That is, for the two states, initial and final, dt is 0 but dv is not 0. By writing this I mean this. Okay, so putting dt equals 0 and dv not equal to 0, yes, which means it would remain as it is, the equation d will now change. So the equation d has now become 1 minus dv by dp isothermal, dp equal by dv, it is also isothermal, dv, the other part has now become 0 because it was in multiplication with dt, which has taken 0, so that part become cancelled. Now since it is equal to 0 and it is in multiplication with that part, we are going to take this to the left hand side, so it would become 0 as well. So 0 equal to 1 minus v by dp. We are close to getting our first deduction from the equation of state. 1 equal dv by dp, simplifying the equation, right? 1 by dp by dv, d is equal to dv by dp. Can you see the relation? dv by dp is equal to reciprocal of 1 by dp by dv. This is our first deduction. This is our formula, which would become a very important equation. Any such relation, any such fraction can be written as reciprocal 1 by, it is in inverted position, dv by dp is equal to 1 by dp by dv. It's reverse, right? We are writing it as equation E. So any partial derivative can be replaced by the reciprocal of the inverted derivative, but the variables would be held constant with the same variable, with the same variables held constant. So this is our first deduction from equation of state. So our first deduction is related to partial derivative. Another deduction is coming up with the same partial derivative, with the help of the same partial derivative. But notice that here we have taken dt is equal to 0, but dv not equal to 0. For our next deduction, we are imposing the condition similarly taking dv is equal to 0, but this time dt is not 0, it is something. So taking this in, what was our equation? It was equation D. So what we are going to do next is, first we are going to write down that equation. 0 is equal to v p t p v t v, right, minus v p p p t v. Let's interchange these sign. From equation E, what we have learned is that we can write any partial derivative in terms of reciprocal of inverted derivation, inverted partial derivative. So we can write this as minus 1 by v by t with the same constants of variable, right? What have I done here is, I wanted to take this, but I took this on the other side. It doesn't matter. So this is that. Now I'm taking this on right hand side, so it would become dvpt multiplied by dv dv multiplied by this region would go there. So v dp is equal to -1. This is our second and final deduction from that equation. Can you see that all of these variables are we both in numerator as well as in denominator as well as in the constant condition as well. First we have dv as a denominator, then p, then v, and then pdt. I guess I have made a mistake. After reviewing it, I get to know that I have taken wrong variables here. V should be in the denominator and t should be in the denominator. So I'm going to replace it with this everywhere. That was a very stupid mistake. VPT and T. Yeah, sometimes mistakes happen. I don't know how I did this, but at least now I have rectified it. So this is how it is. This is our second deduction. Now what I was saying is, now we have every single partial derivative of our three variables, dv by p, p by t, t by v. All of them are written every single time. So v would be in numerator, in denominator as well. T would be in constant condition, v and p as well. You can see that. So these are our two deductions from equation of state. First one is that we can write any partial derivative in terms of reciprocal of inverted variable, and other one is that we can write these different partial derivative in terms of every single numerator, denominator, and constant conditions. So these are very useful deductions.